Hello PU2 champions, welcome to day 14 of 21 days challenge to get 95% in your second PUC board exams. As part of today's challenge, I have given you two chapters for revision. The first one is D and F block elements from chemistry and the second one is your differential equation from mathematics. So you need to revise these two chapters and practice its most important questions from the PDF I have provided. If you haven't downloaded it, don't worry, the link is there in the description section. So click on the link, visit the page and download the most important questions PDF, okay? Because these are the questions that are sourced from PYQs, question bank, model question paper and have a high probability of being asked in your board exams. Now in this video, we are going to discuss the most important questions from the chapter D and F block elements, okay? So very scoring and scoring chapter and you just need to remember certain things, then definitely you can get this chapter full marks. Now let's first understand the blueprint of this chapter. The total weightage is 10 marks. Here you will get 2 3-marker questions, 1 2-marker questions and 2 1-marker questions. So before moving ahead, there is something very important for all of you. KCET 2026 examination is coming, right? So if you really want to get a top rank, a top seat in the top colleges of Karnataka, then only studying will not help you. To crack any exam, one of the most important resource is a good and relevant test series. So to help you with this, I have launched the Fighter KCET 2026 test series, which is based on KCET pattern syllabus and is designed by KCET experts. Here you will get total 18 mock tests, 6 each from physics, chemistry and maths. You will be getting detailed solutions, chemistry video solutions and the most important thing, the test analysis report. Now all these things are available at a very affordable price of just rupees 399. So if you want to boost your preparation and want to make it better, the link is there in the description section. Please check the link and you can purchase this test series, okay? Now let's move to the questions. So first we will discuss 2-marker question. So here the first question is, on what ground you can say that scandium is a transition element but zinc is not? Now the definition of transition element is something where you have unpaired electrons in the unpaired electrons are present in the ground state or in the common oxidation state. But if you see scandium is a transition element as its unpaired electron in the ground state. Scandium electronic configuration is 3d1 4s2. Okay, now but zinc does not have if you see zinc electronic configuration, it is having 3d10. It does not have unpaired electron either in the ground state or in the common oxidation state. So that is why scandium is a transition element but zinc isn't. Next, give reasons copper 2 plus aqueous is more stable than copper plus. So copper 2 plus aqueous is more stable because it has more negative hydration enthalpy. Okay. Next, we'll talk about why Cr2 plus is reducing and Mn plus 3 is oxidizing when both have D4 configuration. Now see, Cr2 plus if you see, okay, that is your D4 configuration. From D4 to it can go to D3, a stable configuration which is T2G3. Now Cr2 plus D4 to D3, here we have Cr3 plus. Okay, so now if you see that from this one plus 2 to plus 3, it is undergoing oxidation, so it will behave as a reducing agent. Now if you see Mn3 plus, its configuration is D4. Now from here it gets reduced to Mn2 plus, which is your D5 configuration. Okay, so Mn plus 3 to Mn2 plus D5 configuration is there, so that is why here it is reduction, so it will behave as an oxidizing agent. So Cr2 plus is reducing because it easily loses one electron to form stable Cr3 plus configuration. Mn plus 3 is oxidizing because it gains one electron to form the stable Mn2 plus half-filled configuration. Next, the E naught value of copper is positive. Give reason for this. This answer is slightly lengthy, but you have to understand here that E naught of value depends on certain factors like atomization enthalpy, first and second ionization enthalpy, and the hydration enthalpy. The atomization enthalpy, first and second ionization enthalpy are positive values, whereas hydration enthalpy is a negative value. Now, for copper, the enthalpy of hydration is relatively low compared to the high enthalpy of atomization and the ionization energy. So, overall, if we see for copper, the atomization and ionization enthalpies are much higher as compared to the negative ionization enthalpy. This means that the energy released during the hydration does not compensate for the energy required for the atomization and the ionization. Since the energy required to form Cu2 plus is greater than the energy released during hydration, the overall process results in a positive electrode potential. Okay. Next, the E naught value of Mn plus 3 to Mn2 plus couple much more positive than that of Cr plus 3 to Cr2 plus or Fe plus 3 to Fe2 plus. Explain. Okay. Now here you can see E naught value of plus 3 to plus 2. Mn2 plus has stable D5 configuration, so Mn3 plus easily gets reduced to Mn 2 plus. Therefore, because it is having a stable configuration, this reduction is very, very easy, and that is why it has a more positive value than Cr and Fe, because here there is no transition from to a stable oxidation to a stable configuration. Next, which is a stronger reducing agent, Cr2 plus or of Fe2 plus, and why? Now, Cr2 plus is a stronger reducing agent than Fe2 plus. In the formation of Cr2 plus to Cr3 plus, the change of D4 to D3, D2G3. But in the formation of Fe2 plus to Fe3 plus, the change is D6 to D5, half filled. Since D3 T2G has lesser energy, it is more stable. Next, we have given it two examples of amphoteric oxide Cr2O3 and V2O5. Calculate the magnetic moment of Ti3 plus, scandium titanium. If you see titanium, it is scandium titanium 3D2 and 4s2. Now, if I have Ti3 plus, it will have argon and 3D1 configuration. Here the unpaired electron is 1. So what is the value of magnetic moment? Root over of 1 into 1 plus 2. That is equal to 1.732. Okay. Next, transition elements form colored compounds give two reasons. The first one is due to the presence of unpaired electrons, and the second one is due to DD transition. Next, the transition metals and the compounds are known for their catalytic activity, give two reasons. It has variable oxidation state, large surface area for adsorption, incompletely filled or partially filled d orbitals. It helps in the formation of intermediate compounds. Next, write any two characteristics of interstitial compounds. They have high melting point and they are very hard. They retain metallic conductivity and are chemically inert. Next, draw the structure of dichromate ion. What is the bond angle of CrOCr in it? So you can see this is the structure of dichromate ion and its bond angle is 126 degree. Next, draw the structure of permanganate ion and manganate ion. So you can see manganate ion structure is MnO4 2 minus. Okay, and permanganate ion is MnO4 minus. Okay. Next, what is the common oxidation state of lanthanides? It is +3. Mention any one consequence of lanthanide contraction. So this question is very, very important and is repeated almost in every paper. So the consequences, you should remember it properly. Zirconium and hafnium have the same atomic and ionic radii. Separation of lanthanides becomes difficult due to the similar size. Basicity decreases as we move from lanthanum to lutetium. Next is what is the composition of mic metal and write one use of it. So mic metal is an alloy of lanthanum metal and iron and traces of sulfur, calcium, carbon or aluminium. It is used in making bullets and lighter flint. Now, what is the reason for that? Separation of lanthanoids is difficult from their natural occurrence. That is because of their atomic and ionic radii. These elements are very small in size, hence their chemical properties are similar and their separation is difficult. Next, study of actinoids is difficult. The reason for that is actinoids are radioactive elements, half-life values are short, and they are prepared in nanogram quantities. Next, we have balanced chemical equation for the reaction of potassium permanganate from MnO2. Write the structure of manganate ion. So here MnO2 is first converted to K2MnO4, and after that MnO4 2 minus undergoes hydrolysis and gets converted to MnO4 minus and MnO2. Next, balanced chemical equation for the reaction of potassium dichromate from chromite ore. So iron chromate gets converted to sodium chromate. Sodium chromate gets converted to sodium dichromate, and sodium dichromate gets converted to potassium dichromate. Next, the balanced reactions for potassium permanganate to convert iodide ion in acidic medium. Okay, iodide ion in acidic medium will give you I2. Next, the in neutral medium, how will this react? In neutral medium, I minus reacts to give you IO3 minus. Okay, you just remember these part are important, that what gets converted to what. Next, potassium permanganate and oxalate ion in acidic medium. So oxalate ion gets converted to CO2 in the acidic medium. Now here there is no reasoning. Okay, you have to just remember that what gets, like I minus on oxidation will give you what. I minus in oxidation in neutral medium will give you what. These species you have to remember, and the reactions. Now how to remember the reactions I have already explained in the one shot video. So please watch that. You have to just know balancing of one equation. You have to write the other equation, balance the number of electrons, and then add them. This is what we have studied in the redox reaction chapter as well. Okay. Next, we have potassium dichromate and iodide ion in the acidic medium. Okay, so now this time potassium dichromate in acidic medium gives you I2. Potassium dichromate sulfide ion in acidic medium gives you sulfur, and of stannous ion gives you S4. Sn2 plus give you Sn4 plus. Next, we'll see a chromide ore A is fused with sodium carbonate in free excess of air and the product is dissolved in water. A yellow solution of compound B is obtained. Now, after the treatment of this yellow solution with H2SO4, compound C can be crystallized from the solution. When the compound C is treated with KCl, orange crystals of compound D is crystallized out. Write the reactions involved in the conversion of A to D. Okay, so first of all, we have here A is iron chromate, B is sodium chromate, C is sodium dichromate, D is potassium dichromate. And here are the reactions. You can see A will give you B, and then sodium chromate will give you sodium dichromate. Sodium dichromate will give you potassium dichromate. Next, a blackish brown colored solid A when fused with alkali metal hydroxide in presence of air produces a dark green colored compound B, which on electrolytic oxidation in alkaline medium gives a purple compound C. Identify A, B and C. Okay, so here A is your MnO2. It reacts with KOH and O2 to give you K2MnO4. Now K2MnO4 on electrolysis gives you KMnO4. Okay. Next, explain the preparation of potassium permanganate from MnO2 with balanced equation. Mention the gas evolved. Okay, so here you can see first MnO2 gets converted to K2MnO4, K2MnO4 gets converted to KMnO4. Okay, and you can see that KMnO4, when it is decomposed or when it is heated at 513 Kelvin, the gas produced is your oxygen gas. Next, what is lanthanide contraction? Mention two consequences of it. The gradual decrease in the atomic and ionic radii of lanthanides from lanthanum to lutetium with increasing atomic number is called as lanthanide contraction. It is due to the poor shielding effect of 4f electrons. The two consequences here are zirconium and hafnium. Separation of lanthanoids becomes difficult due to their very similar sizes and chemical properties. Next, write any two characteristic property of interstitial compounds. High melting point, they are very hard, retain metallic conductivity and are chemically inert. Next, write the balanced chemical equation for the potassium dichromate and iron chromate. We have already discussed this reaction. You have to remember, it is a must question. Every year this question is asked. So please prepare it thoroughly. Practice these reactions 5 to 7 times. Next, what is lanthanide contraction? Write one comparison and one difference between lanthanoids and actinoids with respect to the oxidation states by them. So it is a gradual decrease in the atomic and ionic radii of lanthanoids from lanthanum to lutetium with the increase in atomic number. This occurs due to the poor shielding effect of 4f electrons, which results in the increased nuclear attraction on the outer electrons. Now the comparison in the similarity in the oxidation state is it shows +3 oxidation state. Difference in oxidation state will give you lanthanoids mainly show +3 oxidation state. Actinoids show variable oxidation state like +3, +4, +5, +6 and +7 due to 5f, 6d and 7s electrons. Next, write the balanced chemical equation in the manufacture of potassium dichromate from chromite ore. Okay, so here also we have already discussed iron chromate gets converted to sodium chromate, sodium chromate gets converted to sodium dichromate, sodium dichromate gets converted to potassium dichromate. Next, give the reason for the following. The spin-only magnetic moment of scandium is 0 because it has no unpaired electron. Okay, because it has no unpaired electron. Next, alloys are readily formed by transition elements because of the similar radii. They have similar size, similar characteristics are there. So next, write the structure of MnO4 2-. This is the structure of MnO4 2-. Next, what is lanthanide contraction and mention two consequences of it. So lanthanide contraction is, it is the gradual decrease in the atomic and the ionic radii of lanthanides from lanthanum to lutetium with the increase in atomic number. Now, what is the consequences of that? Due to lanthanide contraction, the atomic radii is same, covalent character increases, electronegativity of trivalent ions increases slightly, basicity decreases from lanthanum to lutetium, standard electrode potential value increases. Next, actinoids exhibit a greater range of oxidation states due to the comparable energies between 5f, 6d and 7s levels. Zirconium and hafnium have almost the same or identical atomic radii, that is because of due to lanthanide contraction. Next, the transition metals and their compounds are known for the catalytic activity. Give two reasons. So the answer here is variable oxidation state, large surface area and presence of incompletely filled or partially filled d orbital. Next is okay, what is mixed metal? So mixed metal we will cover. Okay, this question I have left, but I have covered it in the next slump slides. We'll discuss. Explain the preparation of potassium permanganate from MnO2 with equation. Already you just need to practice equations, no need to write the steps. Okay, so only equations will help you. Already discussed this question. What are transition elements? Give an example. This question is from the model question paper 1. So the transition elements are those which have partially filled d orbitals either in the ground state or in the common oxidation state. You can write any example except zinc. Okay, zinc, cadmium and mercury. What is lanthanide contraction? Mention two consequences, already discussed. Here is a fill in the blanks question. So this is the first this is the first step from the preparation of K2Cr2O7. So in that we use iron chromide. So A is FeCr2O4. MnO2, when it fuses, it gives you K2MnO4, and KMnO4, when it is reacting, it gives you MnO2. Next, we have separation of lanthanoids is difficult from their natural occurrence, and study of actinoids is difficult. So already we have discussed this question. Explain the preparation of potassium permanganate with MnO2 and what is the gas evolved. This question also we have discussed. Considering the elements of 3D element series, right, which is not able to form monoxide, that is scandium, because it has only +3 oxidation state, and it forms SCO3 structure, SC2O3. Next, positive E0 value is for copper. Element used in Ziegler catalyst is your titanium. Okay, trimethyl titanium is used. Next, with respect to transition elements, which element has the highest second ionization enthalpy? That is for copper, because in after first ionization enthalpy, copper plus has an electronic configuration of 3d10. So it is very, very difficult to remove an element from this one. Then lowest enthalpy of atomization is again in zinc, because it has no metallic bonding. Next, write the balanced chemical equations involved in the manufacture of potassium dichromate from chromite ore. We have discussed this question. You can see that this manufacture of KMnO4 and K2Cr2O7 has been asked so many times, right? So please prepare these two reactions thoroughly. Next, write the formula of 3 different types of compounds formed when lanthanide reacts with carbon or heated with carbon. So first it forms LnC2, Ln2C3 and Ln3C. Okay. Right. So children, that's the end of most important questions from this chapter. Now we have already discussed that I have launched this Fighter KCET test series for all of you, which is available at a very, very affordable price of just ₹399 for your preparation. The test is also live, the first test. So please do check this, and the link is there in the description section. And yes, this is a very, very important step for your preparation, and I hope you will like it. So do that, and I hope all of you are completing the challenge. Very few days are left for your exam, so please don't miss or don't waste even a single day. Put your 200, 500, whatever is possible. Put as much as possible now every day till your exams. Okay, all the best. See you soon in the next video.